In this Q&A video, we'll be answering the question, what are volt-free contacts? This question relates to the recent video that Gordon and Rick made on the ferret system from RF Solutions. This is an absolutely brilliant bit of kit for enabling remote control of electrical circuits, and it's small enough to fit in an electrical back box. However, you may have heard reference in that video to something called a volt-free contact, or maybe a no-volt contact, or you may know it as a dry contact. So what's that all about? Well, if we look at the device, you can see that at this end, it's got terminals to connect the incoming supply. And because of the nature of this type of control system, it's made up of lots of electronic components that require a lower voltage than the 230 volts that single-phase circuits use in the UK. The ferret device from RF Solutions can be operated with a supply from 6 to 24 volts DC. These electronics communicate with the remote controller and switch the relay that sits on the PCB. The switching element of the relay is then connected to these three terminals at the other end of the PCB. Now, if the supply voltage was routed through the device to the common contact here, then when the ferret receives a signal, it would pull the relay in, and that 6 to 24 volts DC voltage would appear on the outgoing contact at this end. However, that 6 to 24 volts DC voltage is no good to us if we're going to be operating a 230 volt device like a light fitting. So it's very common for devices like this one and others to have what's called a no volt contact. It's called this because there's no electrical connection to the supply that operates the device. Now, before we go any further, we just need to define a few terms for switching as well. These are normally open, normally closed, and common. These are the typical names of the terminals that are used on relays and similar. The switching mechanism has a permanent connection to the common at one end of the switch inside the relay. This is where you'll usually connect the permanently live conductor. It's called the common because it can make a connection to either the normally open or the normally closed terminal, therefore it is common to both. When the coil to the relay device is not energized, it is said to be in its normal state. That is, the state that it would stay in forever unless you connect it to an electrical supply. From there, we can understand what normally open and normally closed mean. When the relay is in its normal state, or not energized, this contact is disconnected from the common, or open, and therefore we call it the normally open. The other terminal, however, is making a connection to the common, or we can say it is closed, and so we call it the normally closed. Then, when the ferret receives a signal from the remote control, it applies a voltage to the coil of the relay, and the switch moves to the other position, not unlike a two-way switch. The switching mechanism is no longer in its normal state, and so the connection has reversed. The common is connected to the normally open terminal and disconnected from the normally closed terminal. Of course, some devices work a little bit differently. For example, we've got this tiny PLC from Cruise, and it's got 4 outputs or switches that are controlled from inside here, and they are also volt-free. You can see they have a common connection for every 2 outputs. Going back to the ferret from RF Solutions, we can see this is where the volt-free system comes into its own, because we can use those normally open, normally closed and common contacts to switch the voltage of our choice. In this case, anything up to a nominal voltage of 230 volts AC with a peak value of 12 amps or 5 amps continuous running. All we've got to do is bring a permanent line to the common terminal and then take our switched line out of either the normally open or normally closed terminal. If you're using this to control a light fitting, that would usually be the normally open terminal, so the light turns on when the device is energized. So the contacts here are volt-free in the sense that they are not electrically connected to the supply into the control side of the device, and they can be connected to whatever voltage you need to supply your load as long as it's within the acceptable range for the contact. So there we go, that's what's meant by a volt-free contact, and you'll find these in use across lots of different devices. But as always, we want to hear from you. What's the most interesting thing you've ever used a volt-free contact for? Can you think of any useful applications for the ferret from RF Solutions? Please leave your thoughts and questions in the comments section below, and as always, thank you very much for watching.